Another method for figuring out the size of a sample space is to go ahead and create what's called a tree diagram. Now, a tree diagram is useful if we are repeating a trail over and over and over again, like flipping a coin once, 2, 3, 4 times. Also, if we have variables that interact with each other. For instance, are you wearing a seatbelt? Yes and no. And are you killed or do you survive a car accident? So useful if we're doing repetition, also if we have interacting variables. Whenever we start a tree diagram, we start at a single point, choose one of our variables or one trial to begin with, and split it into the possible outcomes we have. So for instance, if I'm flipping a coin, I might split my tree diagram into heads or tails. If I'm talking about wearing a seatbelt or not, I would split it into wearing a seatbelt or not wearing a seatbelt. If I'm rolling a dice, I would split it into 1, 2, 3, 4, 5, and 6. So I go with however many possible outcomes there are for that specific trial. After I've done the first split, I go ahead and I split again if necessary. For instance, if I flip a coin twice, that first part of the tree diagram represents my first flip, and then I go ahead and say, okay, let's say I got a tails on the first one, well on the second one, I could get a heads or a tails. Same with the other option. Going back to my dice example, after I've rolled my 1, 2, 3, 4, 5, or 6, I could talk about, well, I can once again roll 1, 2, 3, 4, 5, or 6 for each of these possible options. Now, this is once again for flipping a coin twice or rolling a dice 2 times. If I wanted to add in more flips or more rolls, I'd split the tree diagram yet again.